For this lab, we are going to be talking about center of mass, and we're also going to use that to help us calculate how we can put things in equilibrium and think about torque as well. So you can think of the center of mass of an object as the average position of all the mass in a system. And the cool thing is that if you find the center of mass of an object, you can balance that object at its center of mass. So here I have my meter stick. I can figure out where the center of mass is of this meter stick by holding it on my finger and finding the place where it balances. Okay, so the meter stick is 100 centimeters, trying to figure out the place where it balances. Okay, so you know, it's interesting though that this meter stick doesn't balance exactly at half its length, 50 centimeters. It actually balances a little bit off from that at about 50.5 centimeters. So that would be the center of mass of the system, which is the average position of all the mass in the system, and I can verify that by trying to balance it on that point. And if we balance it on that point, we've also found the center of mass. Okay, but so we can calculate it experimentally. We'll do that in lab. We can also calculate it, of course, using an equation. So here's the equation we can use to find the center of mass of a system. If the object is in 2 dimensions, then we can calculate the center of mass separately for the x dimension and the y dimension. If we're in 3 dimensions, you can calculate it separately for the x, the y, and the z dimension. If we wanted to find the center of mass of an object, let's say we have a bunch of objects lined up in a row, and we want to find the center of mass of that system. To do that, we can use this equation right here. The center of mass along the x-axis is going to equal to the sum of the mass times the position of each of those individual masses. So if I have 3 different masses and I know their position relative to some reference point, then I can calculate this quantity here. It's going to be the sum of all of our individual masses times their position away from where I set some point to be x equals 0. And then I divide that by the sum of all the masses on their own. So it's kind of a weighted average. So here what I have is a table. We have 3 masses, each of a different mass right here, and they're located at different positions on our xy coordinate system. Okay, so this mass has a different x and y position on the coordinate system than these others here. Okay, so what we can do is we can figure out the center of mass of this system in both the x and the y dimension. So let's just go ahead and draw our system here. Where are these masses? So mass 1 is sitting at minus 11.25 meters, and in the x direction, and in the y direction at 10.95 meters, so it's somewhere right here. I'm going to call this mass 1, okay? And then mass 2 is sitting at 3.16 meters along the x dimension and 6.27 meters along the y direction, so somewhere right here is mass 2, okay? And then mass 3 is sitting at 24.76 meters along the x and minus 14.25 along the y. So it's somewhere over here. Okay, this is where mass 3 is. So I need to find the center of mass of the system in both the x and the y directions. So first, let's just start by finding the center of mass of the system in the x direction. So I'll just directly take this equation right here. We go x center of mass equals, I've got to take the sum of all my individual masses times their position with respect to some place where I'm calling x equals 0. You can choose x equals 0 to be wherever you like. We have a coordinate system here, so the center of my coordinate system is my x equals 0. So here I'm going to take mass 1 times its position from the x-axis, or from where we're saying x is equal to 0, times mass 2, plus mass 2 times its position from where we say x equals 0, plus mass 3 times its position from where we're saying x is equal to 0, divided by the sum of those masses, m1 plus m2 plus m3. Okay, so then that equals, we've got our first mass of 5.46 kilograms times its position from x equals 0 minus 11.25 meters plus my second mass, 4.96 kilograms, times its position from x equals 0, 3.16 meters, plus, oh, the decimals are a little bit hard to see here, okay, plus my third mass, 1.59 kilograms, times its position from x equals 0, 24.76 meters. And I'm going to divide that by the sum of all of my masses, which is 5.46 kilograms plus 4.96 kilograms plus 1.59 kilograms, okay? So I'm not going to break those up into their individual points or anything. So plug in the math whenever you're doing it in your calculator. You might want to do these individual pieces first and then add them all together before you go ahead and punch everything into your calculator. You might want to break it up into segments. Okay, I'm not going to spend time doing that here. And then we find that altogether the center of mass of the system along the x direction is minus 0.532 meters. Okay? So that's our x center of mass. So I abbreviate center of mass with COM, center of mass. And now for the y dimension, we just take this equation. Y center of mass is equal to, will be the sum of the masses times their position along the y-axis divided by the sum of the masses. Okay, so then we have m1 times y1 plus m2 times y2 plus m3 times y3 all over the sum of those masses, m1 plus m2 plus m3. Okay, so we come over here, we look and see that for mass 1, our position away from where we say y is equal to 0 is 10.95 meters. Our position from where we said, for our second mass, our position from y is equal to 0 is 6.27 meters. Our third mass is minus 14.25 meters. Okay, so don't forget to include those minus signs whenever you're plugging everything in. And then we go ahead and plug those in, and we find that the y center of mass is 5.68 meters. Okay, so if I'm locating the center of mass of the system, that tells me that the center of mass of my 3-mass system here is going to be sitting at minus 0.532 meters, so just over on the side, and positive 5.98 meters. So it's somewhere right here, okay? That's the center of mass of my system. And the center of mass of your system is always going to be a little bit closer to the point where the majority of the mass in your system is located.